The depth readings don't match. For 70 years, every textbook has told us the same thing. Challenger Deep in the Mariana Trench is the deepest point on Earth. It's the Everest of the ocean, 10,935 meters, but measurements from another trench in the southern Pacific keep appearing, and then disappearing from official records. Horizon Deep, 10,823 meters. Or is it 10,882? Why do the numbers keep changing? And why did a 1952 expedition record a depth that suggested the Mariana wasn't just beaten, it was crushed? Stay until the end. Because the rivalry between these two abysses isn't just about a number. It's about a geological violence so extreme it distorts the very sound waves we use to measure it. We live on a planet where the highest peak is fixed, Everest, 8,849 meters. We can measure it with lasers from space. But the ocean floor is hidden beneath a veil of physics that makes certainty impossible. You can't use lasers, you can't use radar, you have to use sound, and sound is a liar. There are two titans in the deep ocean. In the north, the Mariana Trench. In the south, the Tonga Trench. For decades, scientists have whispered that Tonga might be the true king. It subducts faster, it's seismically more violent, and its walls are steeper, so steep that sonar beams scatter like light off a broken mirror. If there is a hole deeper than Challenger Deep, it's hiding here, in the shadow of the Kermatic Arc. Tonight, we are going to settle the rivalry. We are taking the most advanced sonar system ever built to the bottom of the world to find out if history is wrong. The controversy began in the Cold War. In 1952, the research vessel Horizon from the Scripps Institution of Oceanography was cutting a line through the South Pacific. It was part of the Capricorn expedition, a mission to map the unknown frontier before the Soviets did. The ship was equipped with the best technology of the era, a single-beam echo sounder. It worked by firing a loud ping straight down and timing the echo. Simple physics. Distance equals speed times time divided by 2. As they crossed the Tonga Trench, the stylus on the chart recorder dropped off the paper. The depth plunged past 6,000 meters, then 8,000, then 10,000. When the crew crunched the numbers, they got a reading that sent shockwaves through the Navy. 10,800 meters, possibly more. In the crude margins of 1950s technology, this was indistinguishable from the record held by the Mariana Trench. The spot was named Horizon Deep in honor of the ship. For years, maps labeled it as a contender. 10,882 meters was the number that started circulating in academic papers. If that number was real, it put Tonga within 50 meters of the Mariana record. A margin of error so thin that a single wave on the surface could flip the title. But there was a problem. The Horizon didn't know exactly where it was. GPS didn't exist. They navigated by the stars. A cloudy night meant their position could be off by miles. They might have missed the deepest point entirely. Or they might have measured a phantom, a depth that didn't exist. To understand why we still argue about this 70 years later, you have to understand what it feels like to descend into a trench. It's not just water, it's a lens. As a sound pulse travels down, it passes through the thermocline, a layer where temperature plummets. Cold water makes sound travel slower, then it hits the deep pressure. Immense crushing weight makes water molecules pack tighter, speeding the sound back up. This constant change in speed bends the sound wave. It refracts just like a stick looks bent in a glass of water. If you don't know the exact temperature and salinity of every single layer of water for 7 miles, your math is wrong. A 1% error in sound speed calculation at these depths translates to a 100-meter error in depth. That's the entire difference between winning the title and losing it. But the Tonga Trench adds another layer of nightmare: slope. The walls of the Tonga Trench are jagged cliffs. Imagine trying to measure the height of a canyon from a helicopter using a flashlight, but the canyon walls are made of mirrors. The sound bounces off the walls before it hits the bottom. This creates ghost bottoms that look shallower than they really are. For decades, the official depth of Horizon Deep fluctuated: 10,800, 10,882, 10,750. It was a statistical ghost. Until 2019, when one man decided to go there himself. Victor Vescovo isn't a scientist, he's a private equity investor with a submarine. In 2019, he launched the 5 Deeps expedition with a singular goal: to dive to the absolute bottom of all 5 oceans. No guessing, no wire soundings, human eyes on the mud. But before he dove, he needed a map. He hired Dr. Heather Stewart, a geologist from the British Geological Survey, and armed her with the Kongsberg M124. This is a multi-beam sonar system so sensitive it can detect a dinner plate at 11,000 meters. The research vessel DSSV pressure drop began mowing the lawn over the Tonga Trench, back and forth, firing hundreds of beams simultaneously to build a 3D model of the abyss. They weren't just looking for depth, they were looking for the error. Dr. Stewart and her team mapped 13,000 square kilometers of the trench floor, an area the size of Jamaica. They dropped landers, robotic pods with ultra-precise pressure sensors to calibrate the sonar. They cross-checked the speed of sound with real-time water samples. They removed the bend from the lens. And the number settled, the data stopped drifting. The result was precise to within plus or minus 10 meters. The depth of horizon deep is exactly 10,823 meters. Challenger deep in the Mariana Trench is 10,935 meters. The difference is 112 meters. It's a decisive knockout. The Mariana Trench is deeper, roughly the height of a 30-story building deeper. But while the number was smaller, what they found down there was far more disturbing. Tonga lost the title of deepest, but it claimed the title of most violent. When Vescovo descended in the limiting factor submersible, he didn't find a serene, sandy plain like the Mariana. He found a chaotic hellscape. The bottom of Horizon Deep is a rocky, jagged scar. And it was alive. In the Mariana Trench, life is sparse. You see the occasional sea cucumber, maybe a plastic bag, but in Tonga, the landers were swarmed. Hadal biologist Dr. Alan Jamieson watched the video feeds in disbelief. The bait canisters were covered in amphipods, huge, pale, shrimp-like creatures within minutes, but these weren't the lethargic scavengers of the north. They were aggressive, large, swarming in thousands. Why? Because the Tonga Trench is a trap. The trench walls are so steep that organic matter from the surface, dead whales, plankton, wood slides down the slopes and funnels into the deepest pits. It's a nutrient funnel. Horizon Deep is a buffet at the end of the world. The creatures here have evolved to withstand 1,100 atmospheres of pressure. That's 8 tons per square inch. Imagine an elephant standing on your thumb. Their bodies are reinforced with specialized molecules to keep their proteins from crushing. If you brought them to the surface, they wouldn't just die. They would melt. Their biology requires the crushing weight just to hold their shape. There is a reason Tonga is so different from Mariana. It's moving, fast. The Pacific Plate is crashing into the Indo-Australian Plate at a speed of 24 centimeters per year. In geological terms, that is a sprint. It's the fastest tectonic collision on Earth. This speed creates violence. The subducting plate is being ripped down into the mantle so aggressively that it tears the seafloor open, creating the vertical cliffs that confuse sonar. It also generates massive earthquakes. This is the engine of the Ring of Fire. The Mariana is old, cold, and slow. It's a deep, settling grave. The Tonga Trench is a fresh wound. It's deeper than Everest is tall, but it's geologically young. And because it's so active, the shape of the bottom is constantly changing. A massive landslide caused by a quake could fill in the deepest point tomorrow or tear it open another 100 meters deeper. This is why the Rivalry never truly dies. 112 meters is the difference today. But in a million years, or after the next megathrust earthquake, Horizon Deep might just catch up. For now, the crown stays in the north. Challenger Deep remains the deepest point on our planet. But the story of Horizon Deep teaches us something more important. It teaches us that our map of the ocean is drawn in pencil, not ink. We have mapped 100% of the surface of Mars. We have mapped less than 25% of our own ocean floor to high resolution. There are thousands of kilometers of trenches that have never seen a multi-beam sonar. We assume we found the deepest point because we found a very deep point early on, but assumption is the enemy of discovery. The Tonga Trench is the deepest place in the southern hemisphere. It is a world of crushing pressure, alien life, and geological violence. It doesn't need to be the deepest to be the most terrifying. If you want to know what happens when you take a submarine to these depths and something goes wrong, click the video on the right. Or if you want to see the footage of the creatures that live in the rock walls of the Mariana, click the video on the left. I'll see you in the dark.